Okay, so we're working on this investigation. We're going to sketch this first one here where y is equal to negative g of x, which is here. And what I notice is that this point 1, 1 is actually down here at 1, negative 1. 4, 2 is down here at 4, negative 2, and so on. And so what's happening is this green graph here has been reflected over the x-axis. And this x, so what we can see here is that if we consider this, we can see that the x is the same, but the y has become negative. It's a reflection over the x-axis. Looking at the next one, we're going to take the negative sign now, and we're going to put it on the inside of the function. So when I take this negative and I adapt my function and I put it here, this red graph here, which is green on the other one, has reflected over the y-axis. So the point is negative 1, 1, and then negative 4, 2, and so on and so forth. And so what we can say here, it is a reflection over the y-axis, and the x value is what becomes negative. Looking at this one here, you should be thinking about what happens here, and I'm going to put the 2 in front. So if I get rid of this negative, make this a 2. Now this value here at 1, 1, it came up here being 1, 2. 4, 2 became 4, 4. 9, 3 became 9, 6. And all the y values get multiplied by 2. And so this is what happens to the graph. It's a vertical stretch by 2. So the x values stay the same, but the y values get multiplied by 2, as you can see here. Now for this one here, add this helpfully. This might be helpful to see if you put on these values here. If we add y equals 1, y equals 2, and y equals 3. All right, and we're going to change this inside here, make it a 2. And so what happens here is now you can see that the y value stayed the same, but the x value is 0.5. The x value is 2 where it used to be 4. The x value is 4.5 where it used to be 9. And so what happens here is this is what we call a horizontal stretch by a factor of half, right? It feels backwards. Even though there's a 2 inside, so it's inside the parenthesis, it's divided by 2. And when we do this one here, this one's often, students find this one, I think, to be the easiest one to get a handle of. If I go plus 3, you can clearly see that the graph is all just shifted up. Even 0, 0 has been shifted up 3, and so this is what we call a vertical stretch or translation by 3. And the x value stays the same, the y value gets added to 3. And finally, if we go x plus 3 inside the parentheses, so we put that 3 inside the parentheses, we can see that this value here shifted over. This one shifted over. This one shifted over to here. Everything gets shifted over 3 units. And so this is what we call a horizontal shift or translation left by 3. And it's opposite of the direction you would expect. So it's x minus 3 is what happens. And so to summarize what's going on, so if we summarize this together, we can say a is a vertical stretch by a factor of a. The y value is multiplied by a and are stretched parallel to the y-axis. So all the y values get stretched parallel to the y-axis. The a value is negative, the function is reflected over the x-axis. So the a has 2 different things, and they both deal with the y-axis. D is here, and it is up or down. It is also a y-axis phenomenon. And so one of the things that I want you to make note of is that this is outside of the function, and this is outside of the function. And they both are y-axis scenarios. They are applied to the entire function. Whereas when I consider the b value and the c value, they're both inside the function, right? They have inside the x value of the function, And so these are going to affect the x values. These are always on the x values. And so b is a horizontal stretch and a factor of 1 over b. So it's opposite of what you expect. The same with the translation. It's in the, if it's minus c, we know it's going the opposite direction of what we would expect. And it's the horizontal translation, and this is the horizontal stretch.